What's up, guys? It's your boy Kaluch, and we're back, and we're going to be in this video talking about how to approximate the area under a curve using trapezoids. Now, we already know how to do that using rectangles, so let's go on and move on and broaden our knowledge and learn that using trapezoids. I'd also like to introduce my fellow partner, Maani Bahador.
How you guys doing?
He's a fellow yo boy Kaluch, and he'll be helping us really on our adventure learning how to approximate the area using trapezoids. Once again, guys, I'd urge you to drop a like, comment, share, subscribe. Please, I want this video to go out to everyone so they can also learn how to approximate the area. And before we begin, I'd like to once again stress one more time very clearly that we are not finding the exact area under a curve, but we are approximating this area using trapezoids, which will hopefully provide an answer that is more accurate. Without further ado, I toss it to Maani.
Alright guys, so let's start out with a basic function, y equals x squared. And we're going to find the area under the curve using the trapezoidal rule from 0 to 2. So what I'm going to like to do is I'm going to draw a graph of y equals x squared. I'm going to label the points. So this is 0, 0. And then let's just say right here, we'd have 1, 1. And then here we'd have 2, 4. So here are our trapezoids, right here. And we're just going to go about this problem the normal way. So we're going to use the trapezoid, the rule. So base 1 plus base 2 over 2 times height. That's how you find the area of a trapezoid. So we're just going to plug in these values. So for the first one, we're going to do 0 plus 1 over 2 times the height. And the height is going to be 1 since we're using two trapezoids. And the width is, it's going to be 1. So it's going to be all this times 1. So that's our first trapezoid. That's going to be this trapezoid right here, which is almost a triangle. And then we're going to add the next trapezoid, which is going to be 1 plus 4. And that's going to be over 2 times 1. So once you add this up, you're going to get half plus 5 over 2, which is just going to equal 6 over 2, which is 3. So that's going to be the area under the curve from 0 to 2 of x squared using two trapezoids. And using the trapezoid rule, you'll get 3. So I'm going to toss it over to Rajit.
Alright, thank you, Maani, for that explanation. But I know what you guys are thinking now. Gosh, there must be a much easier way to do this. And actually, yes, there is an easier way to do this. So let's get about doing that easier way. So let's look at it this way. We can see that the integral from a to b of f of x dx is approximately t of n, where n is the number of trapezoids, equaling delta x over 2. Now delta x is essentially that height aspect of our equation, and because we want it to always be constant, this will always be constant, right? And we're multiplying that by your f of x of 0 plus 2f of x1 plus 2f of x2 plus f of xn, and xn will be your last. Now, looking at this, we can break it down, right? So I've already explained that the delta x over 2 is that, the delta x over 2 is that, right, that base function, right? Because we're adding them up and then we're dividing it by 2. So then we can see, the delta x is, the height function, right? And the over 2 is because in a normal trapezoidal equation, to find the area, it will always be divided by 2. Now if we look here, we can see that there's only one fx sub 0 plus then 2fx sub 1 plus 2fx sub 2, and then it goes back to 1 fxn, right? So to really understand this, we can see that this is because that when you are at 0, only that base is only being counted once. But as you move on, each base is being counted twice up until the very last base. So because of that, this makes sense. This trapezoidal rule it makes sense. And we can use this for whenever we know that delta x is going to be constant. But remember, guys, you have to remember that if delta x is not constant, we cannot use this trapezoidal rule. So we need to remember that delta x, what is it? It's the height, right? The b minus the a. And then we also need to remember that we can only use this rule if delta x is constant. So there you have it, guys. There is your trapezoidal rule. And now let's go about exploring some problems where we can actually use this trapezoidal rule. All right, so let's get right into it, guys. I know you guys are eager to learn, and so am I. So let's start off with this. If we were to evaluate the integral, approximate from 1 to 2 of 1 over x dx using trapezoids, using 5 trapezoids, we will be able to use the trapezoidal equation, right? So we will have T5, n is again the number of trapezoids, T5 will equal, delta x would be the 2 minus 1 over 5, which would give us 0.2, and we know that this will be constant, so we plug that right into our equation, 0.2 over 5 times f of 1, and it would essentially be 1 plus delta x, 2 f of 1.2 plus 2 f of 1.4 plus 2 f of 1.6 plus 2 f of 1.8 plus f of 2, right? We remember that this f of 2 is only being used once. And excuse me, yes, Maani just clarified this. Excuse me, that was my bad. It's 0.2 over 2, right? We use that equation. We know that
It's yo boy.
Exactly. So now let's get about to solving it, right? So we know that 0.2 over 2 will end up being 0.1. This would just be 1 plus 2 over 1.2 plus 2 over 1.4 plus 1.4 plus 2 over 1.6 plus 2 over 1.8 plus 1 over 2, right? And this will ultimately get us to about 0.695. So that will be your answer. And remember, units squared. We are approximating the area, therefore we will need units squared. So there you have it, guys. We have used this trapezoidal rule to approximate this function. Now let's do another practice problem. And it looks to me like this will be our last practice problem for the day, guys. And I really hope this video has inspired you and urged you to explore more into integrals. So let's go right on to the next practice problem. So let's see if we were given a table, right? X and f of x. 0, 1, 3, 4, 7, 8, and 10. And 3, 4, 2, 1, negative 3, 6, and 8. Okay, we can see that the delta x is not constant. Delta x equals not constant. It's not constant, so we cannot use the trapezoidal rule. So what we will have to do is that we will have to do the area of each single trapezoid. So just in the essence of time, I will just be quickly going over this. We should already know how to do this, and that would just be your... So basically, what I've showed you is how to find the area of this first trapezoid. This is trapezoid number 1. And that is basically it. And what you're going to be doing, guys, is you're going to have to do that for each one, okay? Because each one has a different delta x. Ultimately, if you guys do this, if you guys pause this video and do this on your own, you should get the answer 23.5 units squared. So what we have talked about today, guys, we've talked about how to use the trapezoidal rule and how that sometimes the trapezoidal rule is not always applicable if, such as in this case, where delta x is not a constant. Just to wrap it up, once again, thank you guys for listening. Quick shout out to Mr. Happ once again for making us do this project, and thank you guys. Kaluch out.
I also like to point one more thing out. You can use the trapezoidal rule here, except you're doing it for each separate one and you're adding them up. So it's technically still the trapezoidal rule, but you're just doing it for different trapezoids and they're going to have different heights. And yeah, so you're just going to have to add them up. All right. Thank you for watching.
Thank you.
Kaluch out.